Question 2. Two charges minus 2q and plus q are located on the x-axis as shown below. Point P at a distance 3L from the origin O is one of the 2 points on the positive x-axis where the electric potential is 0. How far from the origin O is the other point? So here you have two charges minus 2q and plus q. We can call this as charge 1 and charge 2. They are at a distance of L and 2L from the origin respectively. P is a point where electric potential due to these two charges is equal to 0. We need to find another point away from the origin where the sum of the potential will be 0. So if you have two unlike charges, there can be 2 points where electric potential will be 0, one in between them and the other outside of the two charges. And in both cases, the point has to be closer to the smaller charge. So we already have point P where electric potential is 0 outside of the two charges. The other point where the potential can be 0 would be in between them and closer to the smaller charge. So I will call this point as X. Let X be the position where electric potential due to these two charges is equal to 0. We need to find the value of X. So since total potential at X is 0, we can write total potential to be equal to V1 plus V2, potential due to charge 1 plus potential due to charge 2 to be equal to 0. Since potential is a scalar quantity, there is no direction. We just add the two values and equate that to 0. So V1 will be equal to negative of V2. Potential V is calculated as KQ over R, where K is the Coulomb constant, Q is the charge, and R is the distance of the point from the charge where we are calculating the potential. So I can write V1 to be equal to K Q1 over R1, which is equal to negative K Q2 over R2. Q1 is charge 1, which is negative 2Q. Q2 is charge 2, which is positive Q. R1 is the distance of X from charge negative 2Q, which we can take to be equal to X minus L, which I got by taking the distance formula. Just subtract the two position value. Negative 2Q is at a distance of L from the origin. Subtract this from X to get R1. R2 is the distance of charge 2 from X, which we can take as X minus 2L. I'm taking the absolute value because we do not know the position of point X, so I cannot determine whether this distance will be positive or negative with respect to X. Now substitute here. You can cancel off K and K. Charge Q1 is negative 2Q. R1 is X minus L. Charge Q2 is just Q. Negative sign is from here, not because of the charge, over X minus 2L. You can remove Q and Q as well and the negative sign. So we get 2 over mod X minus L equals 1 over mod X minus 2L. Now cross multiply these two terms. So you get 2 times mod X minus 2L equals mod X minus L. Now, when you take the absolute value of something, we take only positive values. So when I remove the absolute sign, these can be either positive or negative. So I need to decide whether these values of X minus 2L and X minus L is positive or negative. Now, how do we do that? I know point X has to be closer to the smaller charge for electric potential to be 0. So X is definitely greater than L because 2Q lies at a position of L. That means X minus L has to be greater than 0. Since it lies in front of plus Q, X has to be smaller than 2L. That means X minus 2L will be less than 0. So I get X minus L to be a positive number, whereas X minus 2L will be a negative number. So we substitute that here. We get 2. Take X minus 2L to be negative. So negative X minus 2L equals, take X minus L to be positive, so it remains as it is. Now solve. 2 times negative x will be negative 2x. Minus and minus will become plus. 2 times 2 will become 4. So plus 4l equals x minus l. Now rearrange the term. Take l here and 2x over here. So we get 4l plus l equals x plus 2x, or 5l is equal to 3x. Divide by 3, so you get x equals 5 by 3l. So this is the position where electric potential due to the two charges will be equal to 0.